Oh, whoops. Sorry about that, guys. Can you hear me now? I hope everybody can hear me now. You guys with me? I started recording as well. So guys, there's only 3 of us. I'm not seeing Tori. I expect Tori to be here, but I think he has work and he's gonna come home a bit late. But for everybody else, I'll just send him the recording for this before the night is finished. But Denise, you can hear me. Jay, you can hear me as well. Anicia. All right, cool. So, all right, guys. So we on it. We're on it for sure. And we're working with it. So we're going to do this matrices question. Remember, these are the topics. You already did question number 1. No, I didn't, Jay. I didn't start yet. I was waiting 10 minutes until everybody come. So this is the first thing we're starting, guys. These are the topics we need to know. There are only 2 questions on this exam, and it's 1 hour. So it's very short, right? It's 1 hour. It's very short. It's only 2 questions. So it's not a lot of stuff they're going to give you. Cool. And it says here, operations with matrices. So this is what I'm going through first. Cool. This is what I want to go through first. So you're gonna get something related to matrices tomorrow. I'm not sure what it is, but I'm gonna go through a question, a paper 3 matrices type question, to see how it could possibly come, right? So here it says, guys, this is a matrices question. Let's just talk about it. Matrices. And it says in a football tournament, points are awarded as follows: 3 points for a win, 1 point for a draw, and 0 points for a loss. So it says write a 3x1 matrix to represent this information. So guys, another thing with matrices, it's always row by column. Cool. That's how it's always ordered, row by column. So this is saying 3 rows, 1 column. Cool. Does that make sense? Does it make sense to you guys? So 3x1, guys, means 3 rows, 1 column. Make sense? So we'd put it like that. And we have 3 rows, 3 points for a win, 3 points for the win, 1 point for the draw, and 0 points for the loss. 3 rows, 1, 2, 3 rows, row 1, row 2, row 3, column 1. Make sense? Does that make sense to everybody? It's really simple still. Anybody talk to me, guys? Talk to me, talk to me. Talk to me.
Do it again, sir. My phone froze. I'm not sure if you did it.
No problem, no problem. So, all right, so let me do it again. Ready, guys? Ready, guys? So let me do it one more time. So guys, it says in a football tournament, points are awarded as follows: 3 points for a win, 3 points for a win, 1 point for a draw, and 0 points for a loss, right? And it says here, guys, write a 3x1 matrix, 3x1. See it here, let me just underline it again. 3x1, let me rub out this. A 3x1 matrix, P, so P is equal to the matrix, P is equal to the matrix, and it's a 3x1 matrix to represent the information. So this is it, guys, 3, 1, and 0. And why is it that way? Why is it vertical, guys? Because when it says 3x1, it means row by column. Cool? Row by column. This is how we do it. You understand what I mean, guys? This is exactly how we do it. We do it row by column. This is how we always do it. Cool? So there are 3 rows here, row 1, row 2, and row 3. And there's 1 column, C1. Cool? 3 rows by 1 column. And in matrices, guys, it's always row by column. Cool. That's how we write out stuff when it comes to matrices. So the answer for this one, guys, let me just write it over here. The answer here for the 1 mark is P is equal to 3, 1, 0. Cool. Make sense? Make sense to everybody? I did it the opposite way around, horizontally. Yeah, but it's supposed to be vertical. And the reason why it's vertical, J, is because the first one represents the number of rows and the second one represents the number of columns. Cool. So it should be 1 column, which is the second one, and 3 rows. Make sense? Make sense, Jay? Guys? Everybody, make sense to you guys?
Sir, so it should just be 1. What's that, a row? You should just put the information.
Yeah, you're just supposed to write it out and you get the point. As I said, this paper different in it. It's not like a paper 2, believe me. It's kind of simpler still. You just write it out and you get your mark. And that's it. That's it. All you needed to write to get the marks here is this. P is equal to 310 and make sure it's vertical, right? And you get a mark. If you probably put it horizontal, guys, you probably would have get half mark, but yeah, you won't get it right? And remember, the main thing to remember, guys, is always row by column. Cool? Remember that. Row by column. Row by column. Cool? So let's look at the second part here now. It says, during the tournament, Team Alpha recorded 5 wins, 1 draw, and 3 losses. And Team Beta recorded 3 wins, 4 draws, and 2 losses. And it says write a 2x3 matrix R to represent the information above. So first thing we're gonna write, guys, is R, right? And in this case, R is a 2x3. So this means 2 rows and 2 rows by 3 columns. Make sense? So this is the information, guys. They say 5, 1, 3, 5, 1, 3. In this case, it's vertical. Why is it horizontal in this case, guys? It's supposed to be 2 rows and 3 columns. So obviously, that's a setup, 5, 1, 3. And then the next one, 3, 4, 2, 3, 4, 2. So this is the matrix. And it makes perfect sense, guys. The reason why it's horizontal is because 2 rows, there are 2 rows, row 1 and row 2, and 3 columns, right? Where are the 3 columns? C1, C2, and C3. Make sense? Awesome, right? Awesome. My God is awesome. Lead me to the valley. All right, so you got that one right. Well done, Jay. Well done. Well done, Jay.
But being that for the P, I had it
horizontally.
I think the multiplication would have probably been wrong.
Yes, yes. So you don't want to get it wrong, guys. Honestly, you want to try to get it right. And I think with this whole row by column thing, that will make you get it right. Cool. Remember the row by column. Remember that for sure. Cool. Remember that. Cool, guys. So let's go down now to the next part. The next part says calculate the matrix product of R times P. So we need to find RP now, R multiplied by P. So in this case, R is first, 5, 1, 3, 3, 4, 2, cool. Multiplied by, go ahead.
I tried multiplying it with P being horizontal rather, and it almost mad me.
Oh, well, don't worry about it, guys. It's not so bad. It's not so bad, man. I'm gonna show you how to. Don't worry, guys. I'm gonna show you how to, man. It's really not so bad. Believe me. It's not so bad at all, actually. So I'm gonna show you guys how to still.
With P being horizontal.
Right, when it's horizontal, it wouldn't work. It wouldn't work, actually.
It was difficult. It wasn't making any sense to me.
Yes. So it wouldn't work horizontally. So that's why it wasn't working out. So let me just do it for you. Cool. Let's work it out, guys. It's not so bad. Yes, let's work it out. So let me show you guys. Well, let me write it a little better still. I kind of want to write it a little better. So it's R times P, RP, RP. Let me write row by column up here just as a reminder. Row by column, right? Just as a reminder. So in this case, guys, it's 5, 1, 3, 3, 4, 2, right? Cool. Make sense? I think that makes perfect sense. Hold on, let me, English. Okay, cool. English mode, not Vietnamese. All right, so this is it, guys. This is the vertical one. Well, this is the horizontal one, and then the long one, no, I'm gonna write it pretty long. 3, 1, 0. Cool, so we're gonna multiply that out. And let's just multiply it out. Let me put it down here though. So we're gonna open a big matrix like this, but remember guys, how do we multiply again? It's row by column. Same way it's listed out is the same way we multiply. So this is going to end up being, the first space would be 5 times 3 plus 1 times 1, 5 times 3, 1 times 1, 3 plus 3 times 0. Make sense? Make sense? That make a whole heap of sense, don't it? Does that make sense, guys? It make a whole heap of sense to me. All right, and the next one is going to be row. Man, I wish Tori did come early for this, you see. I'm glad to see him though. All right, Tori, good to see you, man. I really glad to see you. So the next one now, guys, same thing, row by column. Cool, let me just show you. Row by column for the second one. So let's do the second one now. Row, column, 3 times 3, plus 4 times 1, 4 times 1, plus 2 times 0. Cool? Yes, so that's how we always do it, guys. Row by column, right? And in this case, guys, we only have 2 rows and 1 column. Cool? So we're going to end up with 15 plus 1 plus 0 and 9 plus 4 plus 0. So we're going to end up with 16 and 9 plus 4 is 13. Yes, 16 and 13. So the answer for RP, let me write it over here. RP is equal to 16, 13. And this is the answer. Yes, this is the answer for sure. Yeah, that's the answer, guys. So, and it makes sense, guys. It's definitely 2 only. And the reason why it's 2 only, guys, is because you only can multiply 1 row by 1 column, second row by the next column, by the 1 column, and that's it. So there are only 2 spaces still. Make sense? I think it makes perfect sense. Yes, it makes perfect sense. So your matrix ends up having 2 rows by 1 column. Make sense? 2 rows by 1 column. Repeat. All right, let's repeat it one more time. Ready, guys? Ready from the top? Let's go through it one more time. One more time. Tori, you with me? Glad to see you, bro. Glad to see you. So we're multiplying these again. We're multiplying it again. Tori, I'm glad to see you here. So I can show you how to multiply it again in this case. So guys, the first one is 3, 1, 0. 3, 1, 0. Right? And I'm multiplying this by 5, 1, 3 and 3, 4, 2. Cool. 3, 4, 2. Yes, yes. And another thing too, guys, the reason why you can multiply these in the first place is because there are 3 columns here and there are 3 rows here. Remember, to multiply something, guys, the columns in the first one the columns in the first matrix has to be equal to the number of rows in the second. Cool? So the columns in the first matrix, guys, has to be equal to the number of rows in the second. That's the reason why you can multiply these. Cool? So you have 3 columns and you have 3 rows. Make sense? Make perfect sense. So that's why we can multiply it. The columns in the first matrix is equal to the rows in the second. So we're going to multiply it now, guys. And when we multiply it, we're going to end up just with 2 rows. Why we end up with 2 rows? Anytime we're multiplying, guys, we multiply row by column. Cool? So row by the column. So let's work it out again. First one is 5 times 3, 5 times 3, plus 1 times 1, 1 times 1, plus 3 times 0, 3 times 0. Cool. Then the next one is 3 times 3, 3 times 3, plus 4 times 1, 4 times 1, plus 2 times 0, 2 times 0. Cool. And we're going to end up with 15 plus 1 plus 0. 9 plus 4 plus 0. So we end up with 16. 5 plus 15 plus 1 is 16 and 13. Cool. So that's the answer. So RP is equal to 16, 13. Cool. Make sense? I think it makes perfect sense, guys.
Yes, sir.
All right. So I think we're okay. I think we should be able to manage this now. All right. And it says here now, what does RP represent? Cool. The last question now, guys, the last part of it. Remember, RP is equal to 16, 13. 16, 13. So it says here, what does the matrix product RP represent? Cool. And guys, let's just scroll up a little bit. So firstly, they gave us the wins, the draw, the losses. Wins, draw, losses. And then remember the first matrix they gave us was 3 points, 1 point, 0 points, right? So the first matrix they gave us, guys, was the points. And the second matrix they gave us was the wins, the draw, and the losses. So if we work out R times P, right, it would actually be, the 16 would be the points for team A. Make sense? For team A. And the 13 would be points for team B. Well, in this case, they call A alpha. So let's say team alpha. And the next one says team beta, right? So it does make sense, guys, because remember, let's just go back to the matrices and show you. So remember the first one here says during the tournament, team alpha, right, had 5 wins, 1 draw, and 3 losses. And then team beta had 3 wins, 4 draws, and 2 losses, right? This was the second matrix, which is R. And in the first matrix, guys, was, it says here, points are awarded as follows, right? For the teams, 3 points for a win, 1 point for a draw, and 0 points for a loss, right? So win, draw, and loss. And if you multiply these by each other, we just get the points, the total points. Make sense? So that's all it was about. Getting the points for the 2 teams. Make sense? Make sense, everybody? All right. So I think that makes perfect sense. So I think we can move on. So now, guys, I'm actually going to stop right there still because everything else on the paper don't really look too, yeah, it doesn't really look too like it follow the questions that we're gonna get. So in terms of operations with matrices, guys, I actually think I might bring up, sorry to distress you still, but I think I'm gonna bring up the paper. I think I'm gonna bring up the paper still. Let me stop sharing for a second. I think I'm going to, okay, sorry. So I think I'm gonna bring up yesterday's paper and go through the matrices section just as a reminder, so that we can manage everything related to matrices. Cool. Yeah, so sorry about that. Sorry to go through the answers for yesterday's paper, but I think it's a good reminder of what you might get, you know what I mean? Especially since you did the exam yesterday. So let's go back into the exam yesterday, guys, the same one we did yesterday, and look at, sorry about that, guys. Let me share about my screen. Okay, so let's go into the exam yesterday, guys. Let's go to the matrices section just for a second. Sorry if it distresses you guys, but it's still a good way to show you that, you know, just in case if you get anything related to what they give you. So let's look at this, guys. Suppose they give you this tomorrow. Calculate the matrix product. This is pretty easy as well. I don't know if you guys got it yesterday. If you didn't get it yesterday, don't worry. It's just so it go. It was a hard paper still, so not everything you were able to get. But let's just do this for an example, right? So let's multiply these out, guys. Remember, guys, it's always row by column, right? So let's do the same thing, guys. Let's do the same thing. Yes, let's put a big matrix here. And we're going to say row by column, right? Row by column. So 5 times 2 plus 4 times 0. Cool. So that's the first place. And then the next one is going to be first row by second column again. So 5 times 1 plus 4 times 3. Then the next one now, guys, is going to be row by column. 5 times minus 4 plus 4 times 6, right? So this is definitely the first row. And then let's do the second row now, guys, just in case something like this comes. Minus 3 times 2, right? Minus 3 times 2 plus minus 2 times 0. Then the next one is going to be minus 3 times 1 and minus 2 plus minus 2 times 3. And then the last one is going to be minus 3 times minus 4 plus minus 2 times 6. Cool. So let's work this out and see what we'll get. Let's take our time. 5 times 2 would give us 10. 4 times 0 would give us 0. 5 times 1 would give us 5. 4 times 3 would give us 12. 5 times minus 4 would be minus 20. 4 times 6 would be 24. Cool. Minus 3 times 2 is negative 6. Plus minus 2 times 0 is 0. Minus 3 times 1 is minus 3. Plus minus 2 times 6 is minus 6. Cool. Then minus 3 times minus 4 is actually positive 12. We got the two negatives multiply and get a plus. And then minus 2 times 6 is actually minus 12. Cool. So when we work these out now, guys, we end up with 10 up the top, minus 6 down here. 5 plus 12 is 17 up here. Minus 3 and minus 6 is minus 9. And then we'll end up with negative 20 plus 24. So this is just 4. And then this down here is 0. So this is the matrix, guys. That's the matrix. 10, 17, 4, minus 6, minus 9, 0. Cool. So this is just an example, guys. Even though it was yesterday's example, I didn't stress you guys out. I hope I didn't stress you guys out. It was only 2 marks, guys. So if you did something, another thing for this question, guys, if you did it yesterday and you did something, you tried, you'll get a 1 mark still, you know. You're not gonna get 0 marks if you try still. Yes, you're definitely not gonna get 0 marks if you try, but if you didn't do anything, yeah, you can expect not to get any marks at all.
Sir, question.
Go ahead.
You stop adding when you get to the second bracket. You stop adding there?
Well, you can only add what? You can only add the row by the column. That's all you can add.
No, man, I did all of that. I did all of that.
Yeah.
But what I'm saying, when you get to the 10, 17, 4, negative 6, negative 9, and 0, you don't add again?
No, not at all. Not at all. Not at all. As I say, you can only add the row by the column that you multiply. You can't add anything else. You have to leave it as is. That's why we got our answer with 2 places a while ago too, you know. You understand me, guys? With the last one we did. And the reason why we got that for the last one we did, sorry, is because there were 2 rows and 1 column. So when you multiplied 3 of them, 310, there were 2 rows and 1 column. So when you multiplied it, row by column, we only got 2 spaces. Remember the 16 and the 13? Because it was 1 row, 1 column, 1 row, 1 column. Make sense? So what I'm trying to say is you can only multiply, you can only add the row and the column you multiply. You can't really add anything else. Make sense? So row, column, row, column, row, column. So you know you're gonna have 3 spaces. Make sense? Then row, column, row, column, row, column, and then you have 3 spaces. Make sense? Make sense to you now, Denise? Denise?
Yes, sir. I'm
Trying to understand?
trying to find another way to understand. Is it that when you multiply 2 by 3, that's what you would call this?
Yeah, this is a
So you'll
sorry
get
about that.
a 2 by 3 for the answer.
Well, this is a 2 by 2 multiplied by 2 by 3. Cool. And we end up with a 2 by 3 as the answer, right? But the reason why we end up with a 2 by 3, Denise, is because, as I said, you multiply the first row by the first column, the first row by the first column, and the first row by the second column, and the first row by the third column. So you end up with 1, 2, 3 spaces. Make sense? Then you did the next one for the last one. You multiplied the second row by the first column, and the second row by the second column, and the second row by the third column. So you end up with 3 spaces down here. So yeah, you can only multiply the rows by a column. That's all. You can only multiply a row by a column. So let me just go back to the last one as an example as well. Let me just go back for a second. Let me go back slowly. Remember the last one we just did was 310 multiplied by 513342, right? So this is first row by 1 column. So we end up with 1 space. Second row by 1 column. So we end up with 2 spaces. And when we did it, we got 16 and 13. Make sense? Is it making more sense to you now?
Yes, sir.
Yes. So it's always that way, guys. When you're multiplying matrices, you can only multiply the row by the column. The row by the next column. In this case, it's only 1 column. That's why I can't do no more for the top one. But for this one now, row by column. Make sense? That's how you multiply, guys. Row by column. Cool. So we did 2 examples. We did one yesterday. We did one today. This one says state why the 2 matrices are comfortable for multiplication. It's the same thing I was saying earlier, guys. The columns in the first matrix have to be equal to the rows in the second. That's why they were able to be multiplied. Number of columns in number 1 matrix must be equal to the number of rows in the number 2 matrix. Cool. This is a rule for multiplying. If the number of columns in the first one is not equal to the number of rows in the second, you cannot multiply it, guys. You can't. Cool. So let me just write the other one as well. 5, 4, 2, I think, and 3, 4, 1 or something like that. Remember, this is the other one we just did, 310. The reason why we can multiply these guys is because they're 1, 2, 3 columns, and row 1, row 2, row 3. Make sense, guys? That's why we can multiply them, because the number of columns in the first one is equal to the number of rows in the second. Cool? Make sense? Make sense? So let me give you another example, guys. Suppose they give us this 2, 1, 4, 6, and they ask us to multiply it by yeah, let's put a 3 now. 3, 1, 0. Let's say they ask us to do that. 2 by 2 by this 3 by 1. Can we multiply these? No. The reason why we can't multiply these, guys, is because there are 2 columns and there are 3 rows. Row 1, row 2, row 3. So we can't multiply them. Why? The number of columns in the first one is not equal to the number of rows in the second. So we can't multiply this one at all. We just can't. Let me give you a good example too. You remember you usually multiply and say row by column? 2 times 3, 1 times 1. Where's the third number? You know, you can't multiply it at all. So that's how you would pick up that something wrong. Make sense? If you're trying to say 2 times 3 and then 1 times 1 and then you don't have a third number, something off. You know what I mean? Something wrong. Make sense? So I think I OD'd this still. I think I did everything possible. Go ahead.
Yes, it makes sense, sir.
All right, it makes sense. So last thing now, guys, let's find the inverse. Remember, guys, sometimes they may ask you to find the inverse. Cool. So I'm gonna do this example that we did on the paper yesterday to find the inverse, just to show you guys how to do it in case you get an inverse tomorrow as well. So how do we find the inverse, guys? Let's call it A. Let's say this is equal to A. How do we find the inverse? The inverse is 1 over the determinant multiplied by the adjoint matrix. Cool. So how do we find the determinant again, guys? The determinant for A is equal to 5 times minus 2. Yeah, 5 times minus 2. Is it plus?
Minus.
Minus, right? 5 times minus 2 minus 4 times minus 3. Cool. Yes, yes, minus. So you're supposed to end up with negative 10 and then minus 12. So you're gonna end up with plus 12. So you're gonna end up with 2. Cool. So that should be the determinant. Make sense? Make sense, guys?
Yes, sir.
Yes, it should make sense. And guys, as I said, the good part about it too, if you didn't get this yesterday, let's say you didn't get 2, but you tried, you put up to here, you'll get some marks, you know, you'll get some marks, you get 1 mark, right? Or 1.5 mark. So you don't always have to get it right to get marks. That's what I'm trying to tell you guys. That's why I like paper 2 as well. I really like paper 2 because you really do get little marks just for putting something. If you put nothing, guys, you're not gonna get marks, you know? But if you put something like this and you say, the examiner will say, all right, they must try and make a little mistake. Let me give him a mark. Cool.
Right,
But,
sir.
so go ahead. Go ahead.
Because in my case with the previous question, I did everything up to the answer that you got, but I went ahead and add the answers again.
Right. So you may actually just get the 1 mark. You know, you may get the 1 mark same way. The examiner might say, oh boy, she just make a bad mistake and still get a mark. Or they may say, boy, she make a foolish mistake and give you a half mark. But you still get marks. As I say, guys, especially if the answer is on the paper, you'll get marks. For trying, you get marks. What you don't get marks for is putting nothing. Like nothing, yeah, that's a problem, you know? That's a problem, which is why I said tomorrow too, guys. Tomorrow, when you get the exam, is 1 hour. Just try it. Clear your mind before the exam and just try everything. Try it. Whether you feel it's right or wrong, try, because you'll get marks, right? Cool. So let's finish up. Let's finish up with this because I want to finish up matrices as quickly as I can. So let's find the inverse, right? The next thing we need to find, guys, is the adjoint matrix, right? So of course, the adjoint matrix is equal to, you switch these, so you're supposed to say -2, 5, right? And then for this one, it should be -4, and this -3 just becomes 3, right? So that's the adjoint matrix. So you should end up with 1/2 times -2, -4, 3, 5, right? And when you multiply these now, the top one is going to be, oh boy, let me give myself some space. Sorry, let me give myself some space right here. Sorry about that. So the top one is going to be -2/2, -4/2, 3/2, and 5/2. Cool. And that would end up being, let me write it up here. The inverse would end up being -2/2 is -1, 3/2, 5/2, and -2. -4/2 is -2. So this would be an answer. Cool. So A inverse, let me write it down here. A inverse is equal to -1, -2, 3/2, and 5/2. So another thing, guys, even Jay was saying to me, Jay talked to me yesterday and said, boy, sir, I fail, sir, fail. I said, boy,
Yes,
Jay,
sir,
I
we
don't think you're failing now.
right, sir.
Yeah, good, Tori.
Get
And I
this
said,
right.
boy, Jay, I don't think you fail still, you know, because truth is you did something, right? And as I asked her about this question, she said she did something. She never do nothing, you know, she did something. So, yeah, so you'd pick up some marks here, you know, you'd pick up a 1 mark, you'd pick up a half mark. You'll pick up marks for trying, you know, if you got it
I got this
exactly
one
right,
too, sir. This is,
you
I
got this
got
one.
this. Yeah.
So that's the saying, guys, like you get marks for trying. Obviously, if you didn't do some, yeah, you lose some marks, but truth is you do get marks for trying. Like you don't get 0 marks for trying, you know? So when I heard what Jay said yesterday, I said, boy, yeah, it was rough. Some of the questions you never answer, but that don't mean you're gonna get 0 marks. You know what I mean? So for this example, this variance question, I'm pretty sure most of you guys never even answer this at all, right? So you lose 5 marks. So fine, you lose the 5 marks for this section. But for other sections that you tried, even if you put some reasons here, you know what I mean? You try, put some reasons, you get some marks, you know? So I'm not saying that everything you may have attempted, some of the stuff you might have left blank, but for the ones that you did attempt, for the ones that you did try, you're gonna get some marks, you know? So, cause believe me, guys, I'm telling you, there's some people who did this exam yesterday and they probably only did number 1 and 2 and the rest of the paper blank. I'll tell you that much.
Yes, sir, we know somebody,
Yes.
and him tell me, sir, that is the number 1 and 2.
Yeah, I'm telling you that there's some people who went in the exam yesterday and they probably did this, and them said Jano, and them say, boy, I don't know nothing else, and them just blank for the rest of the paper. So if you tried something, even if you do half of the paper or 3/4, or you try something, you're gonna get more than most people, which is why I say you probably won't fail. So this is why we're going the extra mile today, because we just want to pass and get through, right? Mark, you want a 2 or a 1 still, but we just want to get through. Like we don't necessarily want to fail. So that's why we're doing the best we can. So
So
we'll
you
finish.
remember,
Go ahead.
sorry.
Go
You
ahead.
remember you were saying you hope they give us an easy pattern question. The
Yeah,
pattern question was quite easy. I like it.
it wasn't bad enough. It wasn't bad. Really wasn't bad at all.
And changing the subject of the formula.
It
Surprise.
wasn't bad. The change of the formula one was easy. Really
Yeah.
was. So I got the matrix question at least. See, good. So I tell you, if you got some guys, there's some people who don't know matrices at all, you know. So for you to say that you get the matrix question, there's some people who leave this part blank, you know. Like how people that leave the beards blank, you know. Anyways, so believe me, guys, as I say, you just need to do better than the rest. When it comes to paper 2, you just need to do better than the rest of the people, because that's how hard it was yesterday. It was hard for everybody, not just for you guys, for the whole island. Cool. The whole Caribbean, actually. So guys, we'll finish with matrices now. I don't think we're going to end up getting anything else. Remember, guys, for the determinant, A, B, C, D, the determinant, guys, is equal to AD minus BC. Cool. And the adjoint, A adjoint is DA minus B minus C. If it's a negative number, guys, you change it to a positive 4. If it's a positive 5, you change it to a negative 5, right? That's how it go for the adjoint. So we're good when it comes to that. The last thing I want to cover with matrices, guys, sorry, I'm doing so much on this little topic here, but the last thing I want to cover with matrices, guys, suppose they ask you to find, sorry, let's go back to the paper. Suppose they ask you to find, after the inverse, suppose they ask you to say A multiplied by A inverse, show that it's equal to I, right? Or the identity matrix. So in case you get that, guys, just multiply the matrix by its inverse and then put this for your answer. This is definitely the answer, 1001. Cool. So that's the last thing. And that covers all of matrices. Cool. So we don't know. Let's move on. As you say, Jay, let's move on to measurement, right? Solving triangles. Let's move on to this, solving triangles. Cool. What kind of lines and graphs of functions and stuff last? Let's move on to solving triangles. Should I go through the question yesterday again? In last paper again? Yeah, because you never know. Maybe they make things similar to the paper. Let's go back to the solving triangles part of the exam. Let's go back to this one, this same one. Remember this question, guys? Let's go back to this one. This is a solving triangle type question. I still going to do more of them though, but let's just go through. Remember, guys, the rules. So, ka, toa. Cool. Make sense? These are the rules. So, katoa. So, katoa. Cool. So, katoa, so, katoa. So, katoa, guys. Remember the rules. Let's look at this question though. This question wasn't too bad yesterday. The diagram below shows a triangle PQR. This is the triangle. Here is 62 degrees. Here is 90 degrees. And the PR, the hypotenuse, is equal to 11. Find the size of angle PRQ. PRQ. So PRQ is the angle at R, which is right here. So that would be 180 minus 62 minus 90. And I think that would give you how much? 38 degrees? Make sense, guys? Makes sense, don't it? 38 degrees. Cool. So that gives you the size of the angle. Is it 38 or 28? 90 minus 62. No, it's 28. 28 degrees. Cool. 28 plus 62 will give me 90. Cool. Yes. So 28 degrees, guys. So here's 28 degrees. Sorry to stress you out with the last paper, but it's a good example. You know, something like this could come tomorrow. Because whoever set this exam as well, clearly them set it in their own way. It was so different yesterday. So let's kind of just go with how things are. And then, yes, so the next thing they ask you guys is find R to Q, which is over here, down here, RQ, here to here, right? That distance. So there are two ways to find it, guys. There are actually two ways to find this still. Yeah, there are two ways. Yeah, there are two ways to find it. You can use this 28 degrees as the opposite side, meaning the angle here, 28 degrees, and put here as the opposite side and here as the adjacent side. And you can say cosine 28 degrees is equal to adjacent over hypotenuse, ADJ over HYP. In this case, RQ is the adjacent and HYP is 11. So you'd end up with cos 28 degrees is equal to 11 over, sorry, not 11, ADJ, the adjacent side, which is RQ, over 11. You multiply both sides by 11. And the adjacent side, RQ, would be equal to 11 cos 28 degrees. Cool. So you can do that. You can do that to find the side. I'm not sure what the side was still. Cos 28, guys. What's cos 28? Let me use my calculator. Cos. No, not cos of 1. Let's put 28, find cos. 0.8828, and then I'm going to multiply that by 11. So this should be my answer, 9.71. Cool. 9.71. 9.71. So RQ is equal to 9.71 centimeters, right? So guys, another thing is, I was talking to Jay, I feel like I talked to Jay the most yesterday. And Jay was saying, boy, she never get the first one, the angle thing, but she used cosine for the second one. So that's a point I'm trying to make to you guys. So she never get the first angle thing, but she said she tried to use cosine for the second one. So if you don't get the first mark, fine, it's just 1 mark. But she tried cosine for the second one. She might not have got the exact value, but then probably give her 1 mark or 1.5 marks for trying. You know, you get marks for trying. As I said, there are some people who left here blank. So you get marks for trying, guys. You do. Believe me, you get a lot of marks for trying. Cool. Everybody okay with this? Everybody understand this now? Is it okay to move on from this and do another type of example?
So do our next example.
Yeah, man, let's do another example, guys. So, boom, we're gonna move on to, let's move on to some examples. I can come out of this paper now. Yeah, 60 math tutor, past papers. And I'm going to go into, what I'm gonna do guys, is I'm going to do a tan example for this case. Sorry. Worksheets. Trig. Okay, so this is what we need. So I'm going to do 3 examples, guys. I'm going to do, the first one I'm gonna do, guys, is angle of elevation example, just in case it come. So this over here, guys, it says a plane takes off at an angle of elevation of 17 degrees to the ground, right? 17 degrees to the ground. And it says after 25 seconds, well, firstly, let's draw the plane. Cool. Let's draw the plane. So plane, meow, meow, meow. Why, that's not a good looking plane still, but yeah, let me draw a plane. All right, so this is the plane. Cool. And it says 17 degrees to the ground. So you know that down here is 17 degrees. Let's draw a ground. Yeah, so that's 17 degrees. So 17 degrees to the ground. So right there is 17 degrees. And it says after 25 seconds, the plane has traveled a horizontal distance. So horizontal distance of 2,400 meters, right? So let's put that, the horizontal distance that the plane traveled. Let's say the plane traveled to here. And let's draw the plane now. This is the plane. And it traveled to a height of 2,400 meters. Cool. So this is what happened, guys. This is what we draw. It's a draw sketch to represent the information. I just drew it. See my little plane here. And this is the plane, and the height is 2,400 meters, right? H, okay, call the height H is 2,400 meters. And it says calculate 2 significant figures. The height of the plane above the ground after 25 seconds. Cool. Oh, whoops. Sorry, guys. Let me read it one more time. Sorry, guys. Read the question slowly, right? After 25 seconds, the plane has traveled a horizontal distance. So horizontal distance is from here to here of 2,400 meters. Cool. Sorry about that, guys. Maybe I was moving a bit too fast. We wouldn't have to draw the picture though, the plane picture. You don't necessarily have to draw a plane still, like you don't have to draw a plane, but you can still put the triangle. You can draw a triangle. So suppose they can draw a triangle tomorrow, you know, they can. It's not impossible. So just suppose, we do not suppose, right? So let's say we didn't draw the planes, but we draw the triangle, right? And the height, this is the height, this is the horizontal distance, which is 2,400 meters, and it's on 17 degrees. And it says here, calculate to two significant figures the height of the plane above the ground after 25 seconds. So this is the height over here, guys, right? And guys, anytime you see angle of elevation or depression, you know it's a tan question. So this is tan 17 degrees is equal to, remember, TOA, opposite over adjacent. So this is opposite over adjacent. In this case, the adjacent side is the 2,400 meters. Remember that the 17 degrees always points to the height. So we're going to end up with tan 17 is equal to the height over 2,400. So how would we find it? We're going to multiply both sides by 2,400. And we're going to end up with the height is equal to 2,400 tan 17 degrees. Cool. So let's find that now. Let's put in our calculator tan 17 tan. And then we're going to multiply it by 2,400. So that's the answer, guys. 733.753. 7H is equal to 733.753. But guys, remember it says also that put the answer in two significant figures, right? So it's in two significant figures, guys. So we need to put it in two significant figures. Remember how to do that, right? We only need two significant figures, 1, 2. So we need to look at the 2 plus 1 place, which is the third, which is this 3. Is 3 greater than or equal to 5? No, it's not. So we're going to add a 0 to the one in front of it. And the answer would be 730 meters for the height to two significant figures. Cool. 730. All right. Well done, Jay. Well done. You're looking good. You're looking good, Jay. All right. So not so bad. Manageable. And yes. So this wasn't too bad. Anybody have any issues with this? Want to move on to one more type? Let's do one more type, guys. One more type of triangle. Let's go up. Well, this one well easy still, but I feel like do it the same way still. So let's do this one over here. It's well easy, but let's do it the same way because you might just get this tomorrow. So guys, hypotenuse is 5. Angle is 40 degrees. It says calculate the length of BD, which is this one over here, the opposite side. Calculate the length of BD and calculate the length of DC, which is the adjacent side down here. So we need to find both of them. So for the first one, guys, we need to find the opposite side with the hypotenuse. So you know that's sine. Sine 40 degrees is equal to opposite over hypotenuse. So we don't know the opposite side. We know the hypotenuse is 5 over 5. So how do we find this now? Multiply both sides by 5. So the opposite side is equal to 5 times sine 40. Put that in our calculators, guys, and we're going to get the answer. I think the answer is like 3.21. I'm not sure. Let me check. Sine 40, put 40 in the calculator, right? 40. Sine, sine, whiny. 0.64. Multiply that by 5. Yeah, 3.213. Cool. 3.213. 3.213, guys. All right. Make sense? This is cool. This is cool. And then the second one now. So, well, firstly, let's say BD is equal to 3.213 meters, right? And then the second one now is DC, which is down here. So we'll have the hypotenuse and we'll have the adjacent side. So that one is best to use cosine. cos 40 is equal to DC, which is adjacent ADJ over the hypotenuse 5 again. So multiply both sides by 5 again. And the adjacent side this time is equal to 5 times cos 40, right? And that's supposed to be equal to 3.81, I think. Let me check it. Let me just check it one more time, just to make sure. Clear. Clear it. 40. Cosine, whiny, cosine, cosi, cosine. Multiply that by 5e and 3.83. Okay, so it's 3.83 meters. And that's the answer for that one. All right. So we'll see where to use cosine, guys. You use cosine when you need to find the adjacent side, and you use the opposite side when you need to find, well, when you need to find the opposite side and you have the hypotenuse, then you use sine, right? So we did 3 questions, guys. Remember, sine is when we need to find the opposite side given the hypotenuse, right? And cosine is usually when we need to find the adjacent side given the hypotenuse. And if they don't want to, angles of elevation type questions, guys, where you don't have no hypotenuse, you use opposite over hypotenuse, well, opposite over adjacent. Yeah, so in that case, guys, where you just have the adjacent side and you don't have the hypotenuse, then you use that one. Cool. So those are the 3 cases. We went through the 3 of them. Do we need to do any more? No, we don't need to do no more. I think we're okay. All right, manageable. So we can manage the solving triangles tomorrow, guys, right? Let's look up any other thing on the papers we got. Any triangles on this? Any triangles on this paper? No, no triangles. Also, guys, remember, please use these stuff up. Use these stuff up just in case. Solving triangles, guys, could include Pythagoras Theorem as well. Cool. So just in case you get a Pythagoras Theorem, remember that the hypotenuse squared is equal to, it's not even here in the formulas, but remember the hypotenuse squared is equal to the adjacent side squared plus the opposite side squared. So in case you get Pythagoras Theorem, use it tomorrow. You can find the area, guys. Remember half base times height. Just in case, just in case. Let me look at the other paper though, just to see if there's any triangles in it. Any triangles in this one? Internal angles for quadrilateral. No triangles really. No triangles. I'm not really seeing any triangles here. No triangles. Yeah, so no triangles, no triangles. No triangles. So let's move on now, guys. Let's move on. Solving triangles done. Operations with matrices done. Let's do these 3 now. Lines, equation of lines. Cool. So guys, man, what they gave you guys in the exam was just so hard related to lines. Yeah, it was pretty hard. But what should I cover? What time is it? It's just 7 o'clock. All right, not too bad, man. We're making good speed. We're doing good. So we just need to do these 3 now, guys. 1, 2, 3. Lines, equation of lines, graphs of functions. Cool. Yes. So let's see if there are any lines on the papers we have. Any lines? Yeah, this is one. Okay, let's look at this one. All right, part B, it says P is the point with coordinates -2, 3, and Q is the point with coordinates -5, -1. Show that the gradient or slope of the straight line passes through the points P and Q is 4/3. So this is a good example of what could come tomorrow. And this is what I usually give you guys, right? y2 minus y1 over x2 minus x1. Channel, I can't believe this never even come last time. Still, I was kind of really upset when it never come, but because it would have been 3 marks for you guys. But just in case this comes tomorrow, so this is x1, y2, x2, y2. So -1 -3 over -5 minus -2, and this is going to give us -4 over -3, which is just, remember guys, if you have two negatives, if you divide a negative by a negative, you end up with a positive, so the answer is 4/3. Make sense? Make sense, guys? Awesome. My God is awesome. Leads me through the valley. Make sense, guys? Hey guys, you tired? Anybody with me?
So you just switch them, the 1 with the 3 and then the 5 with the 2.
The 1 with the 3 and then the 5 with the 2? What do you mean?
The coordinates, because you have
Oh,
-1, -3, but in the first coordinate is -2 and -3.
oh, sorry about that. This is y1, x1, y1. So y2 is -1. Y1 is 3, -3, -3. It's right. Then x2 is -5 minus -2. So -2, which gives me 3, -3, -4 over -3. If you divide two negatives, guys, you're gonna get a positive. So 4/3. I got exactly what they asked me to do. Make sense?
Yes, sir.
All right. So we're good. We're good. All right. So suppose they ask us, Mark, they don't give us anything else in this, do they? Okay. So hold on. This is part C, don't 3B, part I. Where's part 2? Something missing in this paper, though. It's unusual still. Okay, well, let's just continue with this though. Let's say, guys, they ask us to find the equation of the line. For this same question, right? For these 2 points, suppose they ask us to find the equation of the line. Remember, guys, the equation of the line is y is equal to mx plus c. So it would be y is equal to 4/3x plus c. And how would we find the c, guys? We would actually use any of these points, these 2 points. Let me use -2 and 3. So for the same thing, y is equal to 4/3x plus c. I would use 3 when y is 3, x is -2. So this would end up being 3 is equal to 4/3 times -2 plus c. And then, sorry, let me give myself some space here. And then I would end up with 3 is equal to -2 times 4 would give me -8/3 plus c. And then this would be 3 plus 8/3 is equal to c. What's 8/3, guys? I think it's 2 2/3. So 2 2/3 plus 3 would be c is actually, let me rub this out. C is actually equal to 5, big 5 2/3. Cool. So my answer would end up being the equation of the line is equal to y is equal to 4/3x and c is 5 2/3. Cool. So that would be the answer. All right. This would be the answer. Cool, for the equation of the line. If they ask us for the equation of the line. Make sense, guys? Everybody with me? Maybe you guys are a little tired, you want a break? Been going hard. Everybody okay? Jay? Jay, you okay? Anisha, you okay? Tori, talk to me, guys.
Yes, sir. Yeah.
All right. So another thing they could ask us tomorrow. Suppose they ask us, guys, so this is the equation of the line down here. This is the gradient M. Is equal to that. Suppose they ask us, guys, for the midpoint of the 2 points, right? Suppose they ask us for the midpoint for this same situation, big M, right? Suppose they ask us for the midpoint. This is X1, this is Y1, this is X2, this is Y2. Suppose they ask us for the midpoint. What would the midpoint be? X1 plus X2 over 2 and Y1 plus Y2 over 2, which would be -2 plus -5 over 2, which is -7 over 2. So that would end up being -3.5. And the next one, well, -3.5, let me write it like that. And then the next one would be 3 plus -1. So that is 2 over 2, which is 1. So this would be the midpoint, guys, -3.5. X is -3.5. And Y is 1. Cool. Make sense, guys? Make sense to everybody?
Yes, sir.
All right. So the last thing now they could ask us, guys, and that's what they asked you guys yesterday. And that's what I was so upset about, you know, man. I swear I was upset, to be honest. What they asked you guys yesterday was the last thing they usually ask, you know? The first thing they asked you guys yesterday was find the perpendicular line, right? That's the first thing they asked you guys to find yesterday, you know? What they usually ask you the last. They didn't even do it step by step and give you some marks first, and just straight up ask you for the perpendicular line. It was a strange question. I'm gonna do it after this still, but it was very strange. So suppose they ask you for the perpendicular line, right? Well, guys, for the perpendicular line, remember this is the equation of the line right here for the line, right? So to find the perpendicular line, guys, you have to find the negative reciprocal of the gradient. So you have to find negative. Yeah, to find the new gradient M2, you have to find -1 over M1. So this is M1, guys, 4 over 3. So the perpendicular line would be equal to flip 4 over 3, 3 over 4, X plus C, and it would be -3 over 4 because it's the negative reciprocal we need to find. So it's -3 over 4, X plus C, and this would be the perpendicular line. Cool? Make sense? How would we find C? C, guys, would have to use the midpoint for the same equation to find C. So we'd have to say when Y is equal to 1, X is equal to 3.5. So this would be -3 over 4 times 3.5 plus C. And then C would end up being, man, that's a really weird one still. Yeah, C would end up being 1 plus 3 over 4 times 3.5. So let me just put that in my calculator. 3 over 4, 3 divided by 4 plus, well, yeah, 0.75 is 3 over 4 times 3.5. So 2.625, and then I gotta add that to 1. So it would be 3.625. So C here would be equal to 3.625. And my answer here would be, for the perpendicular line, it would be Y is equal to -3 over 4 plus 3.625. Cool? Make sense, guys? Make sense to everybody here? Does it make sense, guys? Let me just check. Jay, I lost you. Denise, I lost you. I'm gonna take a break after this, guys. So just check with me before we take a break. We need a breather. We need to just breathe for a second. Anicia, Tori, give me a thumbs up, guys. Talk to me. Talk to me. Reactions, thumbs up. My God is.
No, sir. How do you find the C for the perpendicular line?
How do you find the C? You have to use the midpoint. You
Yes.
have to use the midpoint.
Sorry,
Where
you,
X is.
sorry.
Go ahead.
You can send me the video if you
Yeah,
have a
man. Yeah,
video
man.
on
I'm
this.
going to for sure. I'm going to. So how do we find the perpendicular line, the C point? You have to say y is equal to -3/4x plus c, and then you use the midpoint values, -3.5, and you put that in the x, and 1, and you put that in the y, and then you solve for c. And when you solve for c, you should get 3.625. Cool. It making sense to you now, Denise?
Yes, sir.
Everybody see how to find the gradient for the perpendicular line? You have to use the gradient here, flip it to 4/3, and then put a negative sign on it. That's how we end up with -3/4. Make sense, guys?
Yes, sir.
All right. And
But sir, question. What
go
if
ahead.
the other line? What if you already have the y-intercept for that line? You couldn't use it back for the perpendicular
Yes,
line?
you can use the y-intercept. You can use the y-intercept. Cool. So, and I'm actually going to go to yesterday's question. That's what I'm going to do.
Yeah, because that's what I did
Yes.
yesterday.
Right. Good. Good. So, why I say Denise, you did better than most people. Serious. If you did that yesterday, you did better than a lot of people. I tell you that. Where's the paper? Where's the paper? Where's yesterday's paper, guys? I just have it up. Let me look at my history. I just had it up. Where is it? It gone? Where is it, guys? All right, I just had it up. I have to go stop again. Stop share for a second. Let me go in my WhatsApp quickly. So I'm going to do yesterday's own so that I can give you guys some clarity about yesterday. Just for a second. Just for a second. Cool. Sorry about that, guys. I need to download that paper right away now. Okay, cool, cool. Yeah, let me download it. Download sick. Yeah, I download it now. All right, cool. Okay, so guys, yes, share again. All right, so guys, yesterday's paper, which is why I was so upset. I really was upset with the paper, you know, man. When I saw it at first, I was like, yo, what is, man? So yesterday's paper, guys, they already gave you the line here. So x plus 2y is equal to 10. They didn't ask you to find the gradient. They didn't ask anything. They just gave you the line, right? They just gave you the line. And they say express it in the form y is equal to mx plus c. So this is easy, guys. It's just 2y is equal to 10 minus x. And y is equal to 10 minus x all over 2. So this would end up being y is equal to 5 minus a half x. Am I right? Express L1 in the form y is equal to mx plus c. Right, so that's L1, guys. That's it. So this is how you're supposed to express it. Well, it's mx plus c. So you're supposed to say y is equal to -1/2 x plus 5. Cool. So this is what they ask you for. So they ask you to do that first. That's 1 mark, but that is kind of simple still. They gave you the line. Cool. So you just need to write this out, put it in the form y is equal to mx plus c. That's all you need to do for the first part. So that wasn't too bad. But the next thing they ask you, as I said, they never ask you to find the gradient. They never ask you for the midpoint. They never ask you, well, I guess they ask you this still, the equation of the line, but the next thing, well, they ask you for the gradient. Oh, that's not too bad. Not too bad. All right, so they ask you for the gradient here for this same line. The gradient m is equal to -1/2. Cool, we just found it. Yes, that's the gradient. And then the last thing, it says determine the equation of the line of line 2. So guys, for line 2, guys, if you look up, line 2 is a perpendicular line, right? It's definitely perpendicular. So how do we find line 2, guys? L2, the equation of the line for L2, guys, given this line, it's actually the same thing. We'll have to find M2, which is the negative reciprocal of the first one. So we need to flip this half, guys, flip the half, the negative a half, we need to flip it. So we'll end up with 2, and we'll add a negative to the negative, so it will be positive 2. So that is this is the gradient for the negative, for the perpendicular line, this line, positive 2. So we're gonna end up with y is equal to 2x plus c. And in this case, just like Denise just said, we already have the y-intercept here. So anywhere the y-intercept is, guys, is what the c value is. So in this case, the y-intercept is -5. So it's -5. Y is equal to 2x minus 5. Cool. But as I said, what I didn't like about this question, guys, is that they didn't ask you to find it with 2 points. You know, usually them give you 2 points, and if I use 2 points to find the gradient, they never ask you for a midpoint. Them just kind of just give you and say find the perpendicular line, which was just kind of daunting to me. What I like about it though, guys, is that it's just 1 mark, 1 mark, 2 marks. So it's only 4 marks they gave you. So I don't mind that. And this down here gave you more marks. So I wasn't really too upset still. I wasn't that upset. I also was upset with this question, guys, this part. But I didn't mind that they gave you this down here. This was still easy. So, I mean, you guys gotta get some marks, believe me. Cool. So everybody get this question now? Everybody understanding what to do? Denise, you got it right, it seems?
Yes, I did, sir.
Cool. So you did, as I said, you did better than a lot of people. Jay, you tried it, right? I remember you say you tried it. Anicia, you tried it. Tori, you tried it, right? Tried something.
Yes, sir.
Yeah, so if you tried something, you're gonna get a little marks. Might not get the full 4 marks, but probably get 2 marks, right? Or 1.5. There are some people who didn't put anything here at all. Let's leave it blank. Jay, you with me? Anicia, you with me? You tried? Cool.
Try. Yes, sir. I'm gonna try.
Yes.
Try it.
As Anicia said she come out of the exam yesterday, and some people said them never even try. It just did hard. Them never even tried. So they never put nothing for almost all the paper. So yeah, if you tried something, you get some marks, guys. So that finishes the line stuff. That's pretty much everything related to lines. Yeah, I think we're good with lines now. An equation of the line. Graphs of functions is left, guys. Graphs of functions. You want to take a break now, guys? 7:30.
Yes, sir.
Yeah, guys, let's take a 5-minute break. It's not healthy to work past an hour and a half without a break. Cool. Well, I mean, you can work up to 2 hours without a break, but yeah, it's good to take breaks. Cool. So I'm going to stretch. I like to stretch in my break. So yeah, I'm gonna stretch. Cool. I'm gonna stretch. So I'm gonna take a stretch, guys, and we'll come back within about 5 to 10 minutes. Cool. All right, guys, so let's finish strong. Shelly and Fraser here. Fraser Price. Let's finish strong, guys. Everybody with me? Ready? Anicia, Denise, Tori, Jay, I see you. So let's finish up. What do we have left again? Sorry about that. Graphs of functions. Cool. So we need to talk about functions just a little bit. Yeah, let's talk about functions just for a little bit, and let's look for a graph of functions type question. So let me just say F graph. Graphs. All right, let me look at functions then. Functions 1. Functions. Okay, so I only seen this one. Let's look at the functions though. Is there any graphs on it? Not really seeing much graphs here though. I would definitely love a graph for the function. I may have to look into one of the papers, past papers for this. Quadratic graphs, part 1. Let me try it. Let me look at the quadratic graphs. Sorry about that. Quadratic equations, graphs. Looking for, all right, so go back to graphs. Graphs. No, it's not coming up. This one not coming up. All right, so let me look for one that's, let me look for a past paper. I think I remember 2017 or 2016 may have had one, a quadratic graph in particular. Trying to remember. One we did the other day had one. Let me just check my downloads really quickly. Sorry about this, guys. Paper 2 is definitely a paper 2. May 2017. Let me look for some of them. Sorry, guys, just trying to find one. 8, 9, and 10. That's the same thing. 2017, 8, 9, and 10. So I think this might be one still. No, this is functions though. Functions, not a graph though. Not a graph. Looking for a graph with the function. Sorry, guys. 2018, 8, 9, and 10. Okay, so this is one. This is exactly one. So yes, I starting to know the past papers like I know the back of my hand. To be honest, I'm getting good at this, you know. I'm getting better at this. Every day I get better at this. So ready, guys? This is definitely a graph with functions question. So let's look at it. Ready? My God is awesome. Leads me through the valley. Ready? Everybody with me, Denise? Guys, be present, be present. It's the last run, guys, last run. Tori, Anicia, be joyful that God is with us. God is with us, you know, guys. God is with us. We're gonna get through. So let's look at this one now. It says, the diagram on page 25 shows 6 points of the function here, 3x plus 1 over x. The coordinates of these 6 points are given in the table below. So they may give you a little table like this, guys. This is a very good example of how it could come for real. And then there's some points, guys, from the function here on the graph. They put some of them there. And then they say here, guys, right? Sorry. And they say here, complete the table above by calculating and inserting the missing values of y. So you get 2 marks just for putting in the missing values. right? So you may get 2 marks just for putting in the values tomorrow. So y is equal to 3x plus 1 over x, right? And we need to put the missing values in it. So there's 0.5 and 2, right? 0.5 and 2. These are 2 values that we need to do, that we need to find. These are the x values. We need to find the y values. So when y is equal to 3 times 0.5, that's when x is 0.5. We need to find what y is, and then plus 1 over 0.5, right? So y is going to be 3 times 0.5 is 1.5, plus 1 divided by 0.5 is actually 2. So you're going to get y is equal to 3.5. Guys, you get a calculator in this exam as well, so don't really fret too much. It's not a paper one where you don't get the calculator. You can use a calculator in this exam. So if you don't know what 3 times 0.5 is, just use a calculator. If you don't know what 1 divided by 0.5 is, just use a calculator. Cool? Then the next one, guys, we're using the same equation. Y, when x is equal to 2, you're going to get 3 times 2 plus 1 over 2. So this is going to end up being y is equal to 3 times 2 is 6 plus 1 over 2. 1 over 2 is 0.5, so it's 6.5. So 6.5 would be here. Make sense, Anicia? Make sense, guys?
Yes, sir.
All right. So it makes sense. Makes sense, Anicia. Makes sense, Tori, Jay, Denise. Makes sense? Cool. Well done. So now that gives us the 2 points. So we're all right. Work out the 2 points and we get the 2 marks. And it says now on diagram,
Sir, I
on the
couldn't see
diagram,
nothing a while ago.
you couldn't see nothing. I know. I realized that's why I was trying to talk to you. But basically, Anicia, all you have to do for this is, remember, guys, we need to put the stuff in the function to get the value. So we just have to put 0.5 into the function and we get the value, and 2 into the function and we get the value. Cool? Make sense, Anicia? Yes, I hope it makes sense. Now, the next one says, on the diagram on page 25, the ordered pairs shown in the table have been plotted except for the missing ones. Use the answer in A part 1 to plot the missing points and connect the points with a smooth curve. So this is what you may get tomorrow, right? I hope you get a curve tomorrow to draw like this. It would be so easy. I really hope you get it. So let's go to this, guys, and look at the curve. So remember the values, guys, is x is equal to 0.5 when y is equal to 3.5. And then, yes, so those are the values. And then the next one is x is 2 when y is equal to 6.5. So we need to put those values in. Let me zoom out just a bit more. Yes, so if we look at it, guys, 0.5 is right here. So I'm going to put a line at the 0.5 here. And then 3.5 is, sorry, let me rub this out. Let me rub these out for a second. So yes, guys, if you look at the graph, it's 0, 1, 2, 3 here for the x. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. So we need to plot the points. We need to plot the points, guys. 0.5, 3.5, and 2, 6.5. So 0.5 is right here. 6.5 would be right here. So this would end up being, well, 3.5, sorry. 3.5 is right here. So this would be one of the points. 0.5 to 3.5, which is right there. And then the next point is 2, 6.5. So 2, guys, let's rub this out over here. 2 is actually right here, right? 2, 3. So 2 is right here. So 2, scrolling up, and 6.5 is right here, right? 6.5 is right here. 3.5 is right here. So 6.5 is there, 2 is right here, so the next point is right here. Cool. And then they said draw a smooth curve. draw a smooth curve with the values that are there. So let me rub out these 2 points now, the 0.5 and the 3.5 and so on. Let me write them down here. 0.5, 3.5, 2, 6.5. These are the 2 points that were added. One is here, right? So one is right here, 2, 6.5 is right here, 0.5, 3.5 is right here. And then they said draw a smooth curve. There's an X like up here. So it's going to come like this. Yeah, so it's going to look, guys. My God is awesome. Lead me through the valleys. Make sense? Make sense, guys? That's how it going to look. And it always look like this, guys. It always tend to look like this or like this, you know? So that is, this is how most of them look, guys. Sometimes they may look like this too, you know? But the most important thing, guys, is that you're not going to be able to draw a vertical line through 2 points. Cool? Guys, a function, remember? Yes. So this is it, guys. This is how it's supposed to look. And sorry about that, Anicia. I guess I need the recording. So everybody okay with this one? In terms of how to draw the curve, it making sense, Denise? Jay? Tori?
No answer.
All right. So we're good. So these are the 3. So we finished with that now, and we draw the curve. So it's not gonna be too bad, guys, man. I tell you, this part might be the easiest part of tomorrow. And then it says, by drawing an appropriate straight line on the diagram, find the approximate solutions for the equation 3x plus 1 over x is equal to 6. So remember the function is y is equal to 3x plus 1 over x, but they say is equal to 6. So they're trying to say that y is equal to 6, cool, on the same graph. So guys, on the graph where y is equal to 6, cool. On the graph where y is equal to 6, guys, y is equal to 6 right here on the graph, cool. And if we just sketch back the curve for a second, we're going to end up with the values for x being, so that's what it's asking you for, guys. It's asking you for the values for x. We're going to end up with the values for x being, I think it's 0.2. 0.2. So at this point where that horizontal line is, they're asking you for that point, which is x is equal to 0.2. And they're asking you for this point, which I think is 2.8. So x is equal to 0.2 and x is equal to 2.8. Does that make sense, guys? Is it making sense to you?
So 2.8 or 1.8?
I think it's, sorry about that. See, well done, Tori. Well done, you're really paying attention, man. That's good. So 1.8, yeah, because this is 2, right? This is 1, and 1.2, 1.4, 1.6, 1.8. Yeah, man, 1.8. Yeah, so that's it. When you draw that horizontal line, you can draw a line right through it with a ruler, basically. Yes, with a ruler right through it. Yeah, if you draw a ruler right through it, guys, you should end up with those values for x. So that's really what they're asking you for. That's really what they're asking you for. Cool. And let me just go over it one more time. One second here. Oops. Whoa. 1 second, guys. Yes, 1 second. Let me just double check it just to make sure. Yeah, so it's definitely 0.2 and 1.8. Cool, definitely 0.2 and 1.8. But let me just go back to the question to see how they asked it. You notice what they did, guys, when they ask you the question? Let me just look at it. It says, remember that the equation is y is equal to 3x plus 1 over x, right? But they ask you, by drawing an appropriate straight line on the same diagram, find the approximate solutions to the equation 3x plus 1 over x is equal to 6. Cool? Yes. So in this case, they're just trying to set us, guys, that the y is equal to 6. And where y is equal to 6, guys, is just the, if you go back to the graph, it's the horizontal line here. Cool? That's where y is equal to 6. That's where y is equal to 6. And if we draw the curve, guys, if we draw the curve, we're going to end up with it looking like, I don't remember how the curve it looks still, but kind of rough. We're going to end up with it like that, pretty much. Yes, I don't remember still, but yes, when you draw the curve, guys, here is going to be 0.2 on the curve. It get cut at 0.2, and the other place that it get cut at is it get cut at 1.8. Cool. So they want the values here where it cut the graph at horizontally, and x would be 0.2 and x is equal to 1.8. So those are the values they want. Cool. So if they ask you that tomorrow, that's what they want. Cool. So I think we're good with that now. We're good. Did they ask you anything else? The speed? No, man, these are different thing. Speed, graph. Okay, so I think we're pretty much done, you know. I think we're almost done now. Yeah, I think we're almost done now. That it said graphs of functions. That's exactly how it will end up being, guys. And I think that's pretty much it. Do I want to go over 2 things before we go, maybe? Just in case we get something strange tomorrow. Cause you know how them stay. The only thing I feel like going through is, it said, let's see what they asked us again. Solving triangles, measurement, geometry, and trigonometry. Solving triangles, lines, equation of lines, graphs of functions. No, I think we're good, guys. I don't think we should OD it still. So I'm not really seeing any of statistics. It never really said that. But I kind of want to go through this one here, the pizza one, just as a measurement question. Should I go through it, guys? How do you guys feel? Think we should take our time?
Yeah, you can go through it.
I think you can go through it. All right, let's just go through this one quickly.
Answer.
Let's just go through this one quickly before we go. So it says the diagrams below represent a cross section of 2 circular pizzas, A and B. So 2 of them is 2 circles, guys, 2 circle pizza. All right, cool. And it says the pizzas are very similar, but vary in size. A has a diameter of 15 centimeters. 15 centimeters is the diameter. And pizza B has a diameter of 30. So pizza B is way bigger, 30 centimeters, right? So it says here, determine by calculation if pizza B is twice the size of pizza A. So guys, what's the area of a circle? It's equal to pi r squared. So this is, if D is equal to 15, R is equal to 7.5 for the first one. If D is equal to 30, then D is equal to 30. R is equal to 15 centimeters here. So for the area for the first triangle, for the first pizza, it's pi times 7.5 squared. And this should be equal to something. Let's work it out. Well, let me give myself more space as well. So yes, that should be equal to something. Let's put it here. A1 first pizza should be equal to, somebody want to work that out for me? Somebody work out 7.5 squared for me, please. And then the second one is going to be A2 for the big one is pi times 15 squared. So this is the A2 is equal to 225 pi because I know that 15 squared is 225 pi. So A2 is 225 pi. And the first one, 7 squared, 56.25. Yeah, that's all right. 56.25 pi, right? I can multiply it by the pi still, but I don't really have to. I can just show that these are not, it's not half the size, it's not twice, because yeah, it's definitely not. So area 1 is equal to 56.25 times pi, and it's not equal to half, not half. It's definitely not half of A2, which is equal to 225, right? It's not half, it's more like a quarter actually, when I think about it. It looks more like a quarter. So 225 pi is A2. And I think it would be more like a quarter, near to a quarter than, yeah. So 225 pi is not equal to, is not 2 times 56.25 pi. So I can tell that these are not equal, no doubt. If I work them out, I would definitely know that they're not 2 times the size. It's not twice, no doubt. It's not twice. Everybody can see why it's not twice.
Right.
Yeah.
I mean, A1 is 176 and A2 would be 706. So.
Yeah, A1 is 56.25 pi, and this one
after
is,
you times it by pi.
yeah, after you times it by pi, we get what? 176. Yeah. And then this one you get how much? Probably something way bigger too. 70, how much?
706.
706. So definitely not twice. I mean, 706 is not 2 times 176. So we can tell it's just not. You can clearly see, you know, and you can work it out, guys, with the pi. But you can obviously see this one really obvious too. This one really obvious. And then let's scroll down now. It says pizza B is cut into 5 equal slices and sold at $6.95 per slice, while pizza A is sold as a whole at $9.95. Cool. So let's work these out now. So A2, it was 706. You said 706 centimeters squared, and A1 was 176 centimeters squared. So they say, guys, this one they cut into 5 slices and they sell it at $6.95 per slice. And this one they sell us at $9.95, right? And it says, determine with reason which of the 2 options, a slice of pizza B or pizza A, is the better buy, right? So one thing for sure, guys, if this is cut into 5 slices, it will be 1/5 times 706. Cool. And let's just put that in our calculators. 1/5 times 706. Whoops. No, 1 divided by 5 times 706. And this will be 141.2. 141.2 centimeters, which is just a little bit smaller than the whole pizza, right? Just a little bit smaller than the whole pizza for A1, sorry. And you get this for $6.95. So obviously, obviously pizza B is a better deal. It's just obvious to me. Yeah, it kind of really obvious that pizza B is a better buy. So pizza B is a better buy because one slice is $6.95, even though it is almost the size of the other pizza. Make sense? So 141 is really close to 176 still, you know, and it costs $6.95. And then this happened to me today, guys. This literally happened to me today. So let me tell you guys a story, guys. My mom is not too well, so today she actually had to go to dialysis for the first time. It was quite shocking, to be honest. It was kind of rough, straight up. It was rough, but yes, it was kind of rough still. But I went and they had coffee there, and one of the coffee sizes, the small cup was 150, and the big cup, which is twice the size, literally twice the size, was 200. So I said to them, yo, it's better you give me the 200, you know, because it just don't really make no sense. Better I take the 200 one, because 150 and it's half the size. It not making sense. If it was $100, no, I'd buy the first one. But 150 for half the size, that don't make no sense. Better you just give me the $200 cup. And this is a good example of that, right? This is a very good example of the fact that it's just a better deal, you know? So in my example, the big cup was a better deal. Yeah, the bigger one was a better deal. But in this example, the smaller one is a better deal. You know, one slice is a better deal than the whole pizza. Cool. So I think these are good examples, though. These are good examples. So it makes sense, guys. That's a measurement question, just in case you get one tomorrow. And I don't think I want to stress you guys out tonight, to be honest. I'm going to keep it at 2 hours. Why do I want to keep it at 2 hours? I want you to get some rest tonight. I want you to get some rest tonight. Why do I want you to get rest? This paper is an hour long, guys. So yeah, you probably want to go over the video if I send in the group in time. I probably send it in the group still. It take a while to process, guys. So I'll probably send it at about 10. But you definitely want to get some rest. Why? The paper is only an hour long. Let's read the paper, by the way. It says here, a list of formulae is provided. On page 4, all working must be clearly shown. Yes. Paper consists of only 2 questions. So it's not a long one. You know, it's not a long one. So you kind of want to get rest. You want to go over some stuff, but you want to get some good rest. And when you manage tomorrow, see, you get a calculator and a geometry set. So you get a calculator for this one. So when you go in tomorrow, you want to treat this one like a sprint. Not to do it fast, you know, but you want to just say, all right, do it, do. You don't really want to like spend too much time thinking. You want to think, you know, but you don't want to spend too much time saying, what do I do? What do I do? You don't really want to spend that much time doing that because it's only an hour you get. So if I were you guys, remember, let's look at what they said coming on the exam. If I were you guys, I'd just do the matrices first, straight up. That's what I would do. I like to do easy stuff first. That's what you're supposed to do, math, guys. I'd just say, oh, let me find the matrices under the matrices. I'd probably do that. Or I'd do the triangles first. It's really up to you. Whatever you find easiest, do first. And then do the rest. You know? Do the rest. You can start from the top if you want. Number 1 is going to be the solving triangles question. So you can do that one first if you want to. But make sure to do this one because you know you understand matrices pretty well. So just make sure to do that part, you know? And then the rest of it now you can say, all right, let me just see what I go on, put in my values, do my thing, and just do it. You know, for this one, just do it. That's what you want going with this exam to say, yo, me I do it still, me I do it. I'm not even a double think, me just I do it. Me just I write things, put stuff. Yeah, man, work it out, you know? Because it's just an hour you get, guys. Feel me? All right, guys. So, yo, let's say a prayer again. Lord, in Jesus' name. My God is awesome. Yes, my God is awesome. Okay, so let's just say a prayer, guys. We're saying some gospel. Yes. So Lord, in Jesus' name, I'm asking you, you gave us a hard road yesterday, but please, Lord, I'm asking you if you can give us the strength to endure tomorrow and finish out on top. I definitely would really like to just pass and get through with this exam, even if I don't do very well. I'd rather just get through. Hopefully I don't have to do this again in Jesus' name. No, I can manage the questions. Sir and me went through all the topics. The Lord is not a ram goat upstairs. You're not a ram goat upstairs, Lord God. Help me to do the easiest questions first. And keep me in the valley, Lord God. You will get me through anything. There's nothing you can't take us through, Jesus. In your name we pray. And thank you so much. Thank you so much for being with me, guys, during this period. Thank you for the exposure, God. I was brave. I decided to try. I really appreciate you adults so much. You guys are very brave. And bravery is usually rewarded. So God, give me the courage and the strength to just finish tomorrow. Please, in your name we pray, amen. Cool. So guys, I'll see you guys tomorrow, right? Well, I'll talk to you tomorrow. Tomorrow is my birthday too, guys. So have a good day. Have a good night, guys. And
Good night.
stay safe and God bless, guys. I'll see you guys later. Cool.
Thank you.
Jay, thanks again. Just push through, Jay. Believe me, you can do it. Denise, same thing. I'll see you later. Cool. My God is awesome. Lead me through the valleys.